Let's solve some previous year gate problems from the chapter bolted, riveted and welded joints. So the first question is for the 3-bolt system shown in the figure, 3-bolt system, the bolt material has a shear yield strength of 200 megapascal. Okay, for a factor of safety of 2, the minimum metric specification required for the bolt is, okay, so tau is given to you, that is 200 megapascal. It is this tau y, that is the shear yield strength, but factor of safety is also given, that is 2. So we actually design the system with the tau permissible, and that will be equal to tau y upon factor of safety, that is it comes out to be 100 megapascal. Okay, so now 100 megapascal, 100 into 10 to the power 6 is equal to force upon the sheared area, the total sheared area. Okay, and the total sheared area is the number of bolts, that is 3, into the area of each bolt, pi by 4 d square. Okay, this is the sheared area, total sheared area. Okay, and the force which has been applied, the shear force that has been applied is 19 kilonewton, that is 19 into 10 raised to the power 3 newton. Okay, so we'll get the diameter in meters, which will be equal to 8.979 into 10 raised to the power minus 3 meter, that is 8.979 mm. Okay, so for bolt, by specification we always take the even number of diameter. We can't take diameter is equal to 8, that is m8, because it will be lesser than what we have found and the compound will fail. Okay, so I mean, the if we take the diameter as 8 mm, it will actually be lesser than this diameter, and this permissible shear strength will actually exceed 100 megapascal. So we have to take something greater than this minimum diameter, and by specification we always take even number of diameters. So m10 is the minimum metric specification required for the bolt. Next problem. The next problem is a bolt of major diameter 12 mm is required to clamp 2 steel plates. Cross-sectional area of the threaded portion of the bolt is 84.3 mm square. The threaded portion. The length of the threaded portion in grip is 30 mm. Okay, while the length of the unthreaded portion in grip is 8 mm. Young's modulus is given. The effective stiffness in mega newton per meter of the bolt in the clamped zone is, okay, so suppose this is the bolt. Okay, so this is the threaded portion in the clamped zone, and this is the unthreaded portion in the clamped zone. So these can actually be compared to the 2 springs attached in series. Okay, so this is the stiffness for the unthreaded portion, that is Ku, and let this Kt be the stiffness for the threaded portion. Okay, so Ku will be equal to Ae by L. Okay, and Kt will also be equal to Ae by L. L here will be different from L here will be different for the unthreaded portion and the threaded portion. Okay, and the diameter of the, I guess the, oh yeah, yes, yeah, so the diameter of the the threaded portion is given, no, the cross sectional, yeah, the cross sectional area of the threaded portion is given, and the diameter is also given for the unthreaded portion, because a bolt of major diameter of 12 mm is given. So I can find Ku by pi by 4 d square into E by L, and d here will be equal to 12 mm. Okay, so pi by 4 d square 0.012 square into E is 200 into 10 raised to power 9 upon L. L is 8 mm. For the unthreaded portion, the length given is 8 mm, that is 0.008 meter. Okay, so this will be in Newton per meter. Okay, this comes out to be I'm writing this in mega Newton per meter because we have to find the effective stiffness in mega Newton per meter. So it will be 2827.4333 mega Newton per meter. Okay, yeah. So similarly, find the stiffness for the threaded portion, and the area, cross-sectional area for the threaded portion is given, that is 84.3 mm square. So that is 84.3 into 10 raised to minus 6 meter square. Okay, and E is 200 GPa, that is 10 raised to 9 Pascal, and the length for the threaded portion is 30 mm. Okay, so that is 0.03 meter. This is also in Newton meter, but I will be writing the answer in mega Newton per meter directly, that is 562 mega Newton per meter. Okay, so now for the series combination of springs, we know that the equivalent effective stiffness will be equal to 1 by Ku plus 1 by Kt. Okay, so put the values, and K effective or equivalent will be equal to 468.815 mega Newton per meter. So this will be the answer, that is 468.815 mega Newton per meter. Okay, next problem. Okay, this is a very common type of problem. You can see this type of problem again and again. I mean, this was asked in 2015, then I guess it was asked again in 2017. So this is a very common type of problem, and it's actually, there is actually a proper proper procedure to solve this type of question. So let's begin. This is the rivet system. Let me draw here. A horizontal plate has been joined to a vertical post using 4 rivets arranged as shown in the figure. The magnitude of the load on the worst loaded rivet in Newton is, okay. So this is the load that is that is acted on this system, and what this distance is given is, this will be actually eccentricity. Okay, this distance represents eccentricity. That means the distance between the line of the application of this load and the distance between the line of the application of the load and the CG, the center of gravity of this rivet system. Okay, so this is this length is 40 mm, and this length is also 40 mm. So this is a square, and the CG of this rivet system will be at the center, and the eccentricity is the distance between the line of the action of force and the CG of the rivet system. So E here becomes 500 mm, that is 0.5 meters. Okay, or 500 mm, whatever you want to take. So this is the CG. Okay, what I can do is I can shift this load on the CG of the rivet system. Okay, but when I will be shifting this load on the CG, on the center of gravity of this rivet system, this force will also be exerting a moment. Okay, and whose value will be equal to, let this be P. So P into E will be the moment that will be exerted when I'll be shifting the load from this line of action to this line of action. Okay, so P into E will be 400 into 0.5. Okay, so this will be 200 Newton meter. Okay, Newton meter, 200 Newton meter. Okay, okay, so then what you do is join the center of each rivet from the center of gravity of the rivet system. Okay, join the center of each rivet from the CG of the rivet system. Okay, let this be rivet 1, this be rivet 2, this be rivet 3, and this be rivet 4. So this becomes, let this be L1, this is L2, this is L3, and this is L4. Okay, so this is this distance is 40 mm, the center becomes 20, and this distance also becomes 20. So L1 is actually 20 root 2. okay, because this is 90, 20, 20. So this is L4, L1, L2, L3, all becomes 20 root 2. L1 is equal to L2 is equal to L3 is equal to L4 becomes 20 root 2. Okay, this is mm. Okay, so 22 root 2 is, I guess it is a 28.28, yeah, 28.284 meters, in millimeters, sorry, 28.284 millimeters. So we have found out L1, L2, L3, L4. Okay, this is actually a procedure how to solve this type of question. Now let's see the effect of this moment and this force on all the rivets. Okay, because we have to find the worst loaded rivet. Okay, so let me draw this system again. Okay, so due to this load, this 400 Newton load, there will be a primary shear force acting on all the rivets. Okay, so this force will be trying to pull all the rivets in the downward direction, so there will be a reaction in the opposite direction. Okay, so let me draw this. Okay, so due to this load, there will be a primary shear force acting on all the rivets and the magnitude will be same. Okay, that is 400 by 4, that is 100 Newton. Okay, I'm denoting it with the, this will be P1 dash, this will be P2 dash, this will be P3 dash, this will be P4 dash. Okay, okay, so P dash is 100 Newton, and what happens due to this movement, there will be another secondary shear force acting on each rivets, and the direction of the secondary rivet, secondary shear force, you can find by this method. When you have joined the center of each rivet with the CG of the rivet system, you have actually done this to find the direction of the secondary shear force due to this movement. Okay, so this movement will actually try to exert a secondary shear force in this direction, that is perpendicular to the line joining the center of rivet to the CG of the rivet system. Okay, so this movement will try to rotate this rivet 1 in this direction, however the reaction will be in the opposite direction. Okay, so let this be P1 double dash. Similarly, for rivet 2, it will try to rotate the rivet 2 in this direction, perpendicular to the line joining the CG of the rivet system and the center of the rivet. Okay, however the reaction will again be in the opposite direction, so this will be P2 dash. Similarly, P3 double dash will be in this direction, and P4 double dash will be in this direction. Okay, this angle will be 90. Okay, 90, this will be 90. Okay, so let me make it more clearly. Okay, this represents the primary shear force, P2 dash, P3 dash and P4 dash. Okay, and the direction of the secondary shear force, it's a bit difficult to draw here, so this will be, this is P2 double dash, this is P1 double dash, and this is P4 double dash, this is P3 double dash. Okay, L1, L2, L3, L4 are is equal to actually 20 root 2 mm. Okay, so the worst loaded rivet will be that rivet in which the angle between the primary shear force and the secondary shear force will be minimum. And in this system of rivets, the rivets 1 and 2, this 1 and 2 are the worst loaded, because theta between the primary shear force and the secondary shear force is the least, and it is equal to 45 degree. Okay, this theta is equal to 45 degree. You can find it because this distance is same, this is also same, this becomes 45, so this also becomes 45 degrees. Okay, now you have found out the primary shear force on each of the rivet, and that is equal to P1 dash is equal to P2 dash is equal to P3 dash is equal to P4 dash is equal to 400 by 4 Newton, that is 100 Newton. Okay, now you have to find the secondary shear force, and for secondary shear force you have to apply these two equations, that is P into E, that is the moment is equal to P1 double dash L1 plus P2 double dash L2 plus P3 double dash L3 plus P4 double dash L4, that is the moment on all the rivets is equal to the moment by this this actual load. Okay, and there is one more equation that you will be using, that is P1 double dash by L1 is equal to P2 double dash by L2 is equal to P3 double dash by L3 is equal to P4 double dash by L4. So using these two equations you will be finding the secondary shear force on each of the rivets. This is equal to constant. Okay, this is L4. So as L1, L2, L3 and L4 are same, so that implies from this equation number 2, P1 dash double dash is equal to P2 double dash is equal to P3 double dash is equal to P4 double dash. Okay, because L1, L2, L3 and L4 are same, so P1 double dash is equal to P2 double dash is equal to P3 double dash is equal to P4 double dash. Okay, put this equation that we have got in 1, you will get P into E is equal to 4 times P1 double dash L1. Okay, now we have P which is equal to 400 Newton, E is 0.5 meter is equal to 4 into P1 dash that we have to find, and L1 is 28.284 mm, that implies 28.284 into 10 raised to power minus 3 meter. Okay, so that implies P1 double dash will be equal to P1 double dash is equal to this will be coming out, the value will be 1767.769 Newton. Okay, so this will be the value. So P1 double dash is equal to P2 double dash is equal to P3 double dash, and it is equal to P4 double dash, and hence we have found out all the secondary shear forces and the primary shear forces. Okay, now all you have to find is the magnitude of the load on the worst loaded rivet, and you know the worst loaded rivet, that is 1 and 2. The magnitude can be found out by simple vector addition, that is P1 dash square plus P1 double dash square plus 2 P1 dash P1 double dash cos theta. Okay, theta is 45 degree, P1 dash you know, P1 double dash you know, find it. The answer will be equal to 1839.836 Newton. Okay, so this is the procedure, or this is how you actually solve these type of questions. So I've explained the logic behind this question also, and I've explained the procedure also. Okay, so first of all you have to find the CG of the rivet system, shift the load from the actual line of action to the CG of the rivet system, and there will be a moment, and due to this there will be a moment also acting on the CG. Then you have to find the distance between the center of the rivets and the CG of the system, that is L1, L2, L3, L4, and then you have to find the primary shear force, then secondary shear force by using these two equations, and then the resultant magnitude of the load on the worst loaded rivet. Okay, next question is, pause करना है यहाँ पे यार. Okay, मैं यहाँ से दोबारा start कर रहा हूँ. A cantilever bracket is bolted to a column using 3M12 into 1.75 bolts PQR. the value of maximum shear into नहीं होता है बे, काटना है यहाँ से, दोबारा काटना है. ओके, यहाँ से शुरू करना है. A cantilever bracket is bolted to a column using 3 M12 bolts PQR. The value of maximum shear stress developed in the bolt P. Okay, again the same type of question that we have to find the primary shear force due to this load acting and the secondary shear force due to this 9 kilonewton load acting on PQR. Okay, so I will not be repeating the entire process. I will be just solving the question with the process that I have told you in the previous question. Okay, so now draw the rivet system. The CG of this rivet system will be at the center of this rivet 2. Okay, let this be 1, let this be 2, and let this rivet be 3. Okay, so you have to find the maximum shear stress developed in the bolt. Okay, so this is a bolted joint, but the procedure is entirely same. Okay, so the CG of this bolt system lies at the center, I mean lies at the bolt 2 itself. So let the line joining the center of the bolts to the CG of the bolt system be drawn. So let this be L1 and let this be L3. Okay, L2 in this case will be 0 because I have told you that the entire that the CG of the bolt system is actually lying on the bolt 2. Okay, so due to this 9 kilonewton load, when I'll be shifting this load here, okay, there will be a secondary shear force in the upward direction due to the reaction. Okay, and that will be equal to 9 kilonewton by 3 because there are 3 bolts, so that is 3 kilonewton of primary shear force will be acting on each bolt, which is equal to P1 dash is equal to P2 dash is equal to P3 dash. Okay, so the direction is this. This is P1 dash, P2 dash, and this is P3 dash. Okay, this is L3 and this is L1. Okay, now when I'll be shifting this load here, there will be a movement in the clockwise direction. Okay, and the moment will be equal to 9 kilonewton, that is 9 into 10 to the power 3 Newton into 0.25 meter, because eccentricity will be this 250 mm, which is given to you. Okay, so this is actually P into E that will be shifting here. Okay, so the direction of the secondary shear force on bolt 1 and 3 will be like this, that this moment will try to rotate the bolt 3 in this direction. However, the reaction will be in opposite direction. So this is P3 double dash, and in this direction it will be P1 double dash. Okay, so let me draw this system, bolt system again. P1 dash, P2 dash and P3 dash, these are the primary shear forces, and this is the dotted line at that angle 90 degree. This is P3 double dash and this will be P1 double dash, that is secondary shear force on bolt 3 and 1. There will be no secondary shear force on bolt 2 because it is actually lying on the CG of the bolt system. Okay, so again use those two equations that I have told you, that is P into E is equal to P1 double dash L1 plus P2 double dash L2. This will be actually 0 plus P3 double dash L3. Okay, and P1 double dash L1 will be equal to P3 double dash L3. That will be equal to constant. So now we have to find L1 and L3. So as L1 is 30 and L3 is also 30, so L1 is equal to L3 is equal to 30 mm, that is 0.03 meter. So that implies the secondary shear force acting on bolt 1 and bolt 3, that is P1 double dash and P3 double dash, are equal. Okay, so P1 double dash is equal to P3 double dash put this question here, and you will be getting that 9 into 0.25 is equal to twice of P1 double dash L1. L1 is 0.03 meters, so that implies P1 double dash will be equal to 37.5 kilonewton. Okay, I've written the load here in kilonewtons only, so P1 double dash is 37.5 kilonewton. Okay, so they have asked me the value of maximum shear stress developed in the bolt P, that is in the bolt 1, and the angle between the secondary shear force and the primary shear force is 90 degrees. Okay, so the resultant will be equal to root of P1 dash square plus P1 double dash square plus twice of P1 dash P1 double dash cos 90. This becomes 0. Solve it. The resultant value will be equal to P resultant will be equal to 37.61 kilonewton. Okay, but you have been asked to find the maximum shear stress, okay, not the maximum shear load. So for the maximum shear stress, tau max will be equal to P resultant upon pi by 4 d square. What will be d? See, this is M12 bolt, so the diameter will be 12 mm, that is 0.012 meters. Okay, put all the values. Tau max, the maximum shear stress developed in the bolt P will be equal to, I guess it will be equal to 332.632 megapascal. Okay, 332.632 megapascal. यहाँ पे भी एक ब्रेक लगेगा यार 26 के आसपास भी. चलो स्टार्ट कर रहा हूँ. नेक्स्ट क्वेश्चन. The next question is a bolted joint has 4 bolts arranged as shown in figure. The cross-sectional area of each bolt is 25 mm square. A torque of 200 Newton meter is acting on the joint. Neglecting friction due to clamping force, maximum shear stress in a bolt is. Okay, so this circle which is passing through the center of each bolt has a diameter of 100 mm. Okay, this is also given. So let's draw the bolt system here. Due to this torque in the anti-clockwise direction, okay, there will be actually a shear force acting on each of the bolt in this direction. Okay, but the reactive force will be in the opposite direction. So that implies this will be F, this will be F, this will be F, and this will be F. Okay, perpendicular to the CG, perpendicular to the line joining the CG of the bolt system and the center of the bolt. Okay, so this will be F, and the total torque acting is 200 Newton meter. So actually we have to find this, the value of F acting on each bolt, and that will be equal to 200 is equal to the number of bolts are 4 into F into R. Okay, so this will be 50, which is equal to F into R, and R or L we denoted by L. So this will be L. So L is equal to 50 mm. So that is 50 by 50 into 10 to the power minus 3 meter is equal to F. That implies F will be equal to 1000 Newton. Okay, the question is based on the previous concept only. So F is 1000 Newton, and the maximum shear stress in a bolt will be equal to F upon A, and the cross-sectional area of the bolt is given as 25 mm square. So that implies 1000 Newton upon 25 into 10 to the power minus 6 meter square, and this is Newton. So Newton per meter square is megapascal. Sorry, Newton per meter square is Pascal, and 1000 by 25 is 40 into 10 to the power 6. 10 to the power 6 with the Newton per meter square. This is megapascal. So the answer is 40 megapascal. Okay, the maximum shear stress in a bolt is 40 megapascal. Okay. The next question. Next question is, consider the schematic of a riveted lap joint subjected to a tensile load F. The figure is given. Let D be the diameter of the rivets and SF be the maximum permissible tensile stress in the plates. SF is the maximum permissible tensile stress in the plates and D is the diameter. Okay, what should be the minimum value for the thickness of the plates to guard against tensile failure of the plates? Very basic, very simple question. That for limiting case, okay, the maximum stress, the maximum permissible stress, tensile stress, is equal to the force, the tensile load upon minimum cross sectional area, okay, and the minimum cross sectional area will actually be equal to, this is W minus the diameter of these two rivets. Okay, so maximum permissible stress is SF, which is equal to F upon minimum cross sectional area is width minus twice of D into the thickness of the plate. Okay, this thickness. So this is the thickness, and this is the rivet. So the minimum cross sectional area will be equal to, this is D, width minus the diameter of this rivet and the diameter of this rivet into this thickness. Okay, so so we can find out T from here. That is, T is equal to F upon W minus 2D to SF. Okay, so this is the answer. Whatever be the option, this is the answer. This will be the minimum value of thickness. Okay, if the value falls below this thickness, the plate will fail. Okay. Next question. Again the same type of question. See, this type of question has been repeated 3 times, so yes, it is important for GATE exam, and I've told you the procedure, how to solve it. So locate the CG of the this is a bolt system. Bolt ABC carries a load of 6 kilonewton. This is let this be P, and the eccentricity you can find out when you find the CG of this bolt system. Okay, so read the question first. Steel plate connected to a fixed channel using 3 identical bolts A, B and C carries a load of 6 kilonewton as shown in the figure. Consider the effect of direct load and moment. Okay, they have given that you have to consider the effect of direct load and moment. Direct load will be giving us primary shear force, that is P dash, and this moment will be giving us secondary shear force, that is P double dash, on each bolt. You have to find the magnitude of resultant shear force on bolt C, on this bolt. Okay, so let this bolt be 1, this bolt be 2, and this bolt be 3. So you have to find the maximum, the magnitude of resultant shear force in kilonewton on bolt 3. Okay, the options are given to you. So let's find the CG of this bolt system first. So the CG of this bolt system will actually lie on bolt 2, because this distance is 50, this is also 50, and that implies eccentricity becomes 170 plus 30 plus 50, that is 250 mm. This will be the eccentricity. Okay, so the primary shear force will be acting in the upward direction, and draw this dotted line. Okay, about the CG, the moment by this 6 kilonewton load will try to rotate bolt 3 in this direction. However, the reaction will be in the opposite direction. And about the CG, this moment will try to rotate bolt 1 in this direction. However, the reaction will be in the downward direction. Okay, so this is P3 dash, P3 double dash, this is P1 dash, this is P1 double dash, and there will be no secondary shear force acting on bolt 2 because it is lying on the CG of the bolt system. However, there will be primary shear force, and that will be in the upward direction, which is that is P2 double dash. Okay, so we have to find the magnitude of resultant shear force on bolt 3. Okay, so the resultant shear force will actually be equal to P3 dash plus P3 double dash. Okay, because the angle between these two forces is 0, so P3 dash plus P3 double dash will be P resultant on bolt 3. Okay, so P3 dash, that is primary shear force, P3 dash is equal to P2 dash is equal to P1 dash, which will be distributed. This 6 kilonewton will be distributed between these three bullets. That is this 6 kilonewton will actually be distributed equally between these three bolts. That is 6 by 3, that is 2 kilonewton. So this will be the magnitude of primary shear force acting on each bolt. Okay, for secondary shear force, you have to apply those two equations, that is P into E is equal to P1 double dash L1 plus P2 double dash L2 plus P3 double dash L3. This is 0, and the next one is P1 double dash L1 is equal to P3 double dash L3. So L1 is equal to L3, the distance is 50 mm, and that implies P1 double dash is equal to P3 double dash, and that will give me P into E is equal to twice of P1 double dash L1. Okay, so P is 6 kilonewton into E is 250 mm, that is 0.25 meter, is equal to twice of P1 double dash that you have to find, and L1 is 50 mm, that is 0.05 meter. Okay, so P1 double dash will be in kilonewtons because I have put the P in here in kilonewtons, put the load here in kilonewtons. Okay, so P1 double dash will be equal to 15 kilonewton. Okay, and P1 double dash is 15 kilonewton, that implies P3 double dash is also equal to 15 kilonewton, and the resultant magnitude of shear force on bolt C will be equal to 15 plus 2, that is 17 kilonewton. So where are the options? Yeah, option C is our answer. Okay, so this type of question is very important for the gate examination, and I have explained this thoroughly, I mean. Okay, so do prepare this type of question. Thank you.